Good evening to all. Welcome to Energy Material Research and Fund. Today with us, Dr. Avantika Hasija and Dr. Sujay Bandhopadhyay. It is my immense pleasure to introduce Dr. Avantika Hasija. Currently, she is a researcher at University of Lorraine, France. She has published so many reputed journals such as Small, Crystal Growth and Design, etc. And her one paper was highly highlighted and also published in magazine. That paper was published in Small, and in that work, their group highlighted that how they prepare the develop organic crystalline material for highly sensitive pressure sensors. So it is my immense pleasure to invite Dr. Avantika Hasija. Recently, you also published, like your work was highly highlighted in all over the world, and also in India. Also, that magazine also came and they published also your work also in a reputed in a prestigious journal in Small. What you will give, because maybe you also faces you have you faced any frustrations and in during your PhD research, of what will be you will give the suggestions to the new researchers?
Well, I'm not the best person to give suggestions to beginners because I really I did not expect to have big papers, to be honest. My focus was never that. It was just out of curiosity that one after the other project, worked out fine and I got good results. So I just kept my curiosity alive throughout.
Yeah.
And one thing that my supervisor, initially for us, it was frustrating, but later on, it was very supportive. He actually pushed us a lot to spend time with the instrument. And the more skills that you learn throughout your PhD, either you will be a master in your skill or you'll increase your observation power. So both of these are good for your research. Data analysis you do, and then with practice it increases, but you need skills for job ahead. And the more time you spend, it's just a probability game basically. The more time you spend, the more you tend to learn.
Get the result.
So
yes. Yeah. Thank you, Avantika. It's very nice to talk with you. And also, can you tell about little bit about your research also, means regarding your small work, that whatever is published, means what is the journey of getting that work? Because whatever you say, that as a new researcher, we should have some curiosity. If they have some curiosity, don't expect it will go bigger for them. If they solve the curiosity and if presented very well, then it will automatically it goes to her forum. So if you tell about little bit journey about your work, it will be motivated.
Yes. And also one more thing also we should learn from Dr. Avantika, that she also told that she do not expect that we need good paper and all, but we only focus on our work, on the instrument part, on the observation part. So if we will focus on our work, then maybe it will go to a like in a next level, like that work highlighted on high pressure sensitive sensors. So mainly we should all researchers should focus on their work first. Later, then they will decide that whether it will go to a good journal or not. That will be the next case. But first, we have to focus on our work. So
yes, and I believe it is necessary for all the researchers to see a mirror once in a while to be sure, you should know where you stand. It's not just, I also used to read nature paper and, we used to get these sarcastic comments from our colleagues saying that, अच्छा, nature पढ़ रहे हो, मतलब nature छापोगे. नहीं, पर उससे आइडिया लेके कुछ तो कर सकते हैं ना. Inspiration can come from anywhere, from the smallest to the biggest journal or the oldest to the newest paper. You never know. So I think with this work, so basically this was we initially started this project with the just, I had a few compounds in my mind which I wanted to crystallize and see how they go, because we were trying to find some mechanical flexibility in crystals. And this particular compound, it is a very small basic compound. I mean, nobody would even bother to see. Generally, we make so complex synthesis and complex
Yes.
molecules, and then we study them. But for this particular molecule, this is a very small basic 4CF3 substituted phenyl isothiocyanate. That's it. And we crystallized it. And what was strange was that when crystallizing, it was subliming. So there were a few anomalous properties with
Okay.
that. And then, because it was subliming, I tried sublimation crystallization. So as soon as we heat the sample, it was subliming and crystals were formed on the test tube. And in that, I noticed that few of the crystals were bent actually. They were grown bent itself, few of them. So that made me think that what could be the possible reason. So after that, we did a few experiments and we saw that those crystals actually can bend, twist, coil. And coiling of crystals have not been known much, especially in organics. It is not. Generally, it has been, you know, the general thought process is crystals are brittle, right? But
Yes.
for this case, we had these flexible crystals. Now, from past 1 decade, there had been research where there are several, organic systems which show uh, organic crystals which show flexibility.
Means these
But
crystals can be, means like flexible means.
yes,
Okay.
basically, if you use a forceps and one needle and keep the crystal like this, you are able to bend it. So on bending, it can either be elastic or plastic. So I have other papers also where I talk about a JMAT C paper, Journal of Material Chemistry C, and a CGND, where crystal growth and design, where I talk about two different systems. Uh, there are multi-component systems which shows elastic bending in crystals. And this particular system was showing plastic crystallinity. That means when we bend the crystal, it stays in that shape. It does not reverts back to the straight shape. So now this was intriguing, but the literature suggests that there had been a lot of recent discoveries of flexible crystals. So we had this question ahead of us. First of all, why we are able to see coiling and twisting in this particular crystal. Bending was
Yes.
common, but not coiling, because coiling requires
Coiling.
two, motion in two different directions. The molecule is actually moving in two dimensions. So this was one question. And the other was, okay, we have got a flexible crystal, now what? Because there had been a lot of reports, and in most of the papers they suggest that these can be applied in optical waveguides and mimicking biosensors and a lot of other wearable electronics. But then where do we see that, right? Stating a line or
Yes.
so is,
Yes.
it's good, it's nice, but we don't see their actual
Yes.
application.
Practical application we need.
Yes. So with the help of two of our collaborators, we were able to then find answers to these questions. So with our collaboration with Dr. Professor Clegg in Australia and his team, we were able to do sophisticated synchrotron measurements where the crystal was bent, and then X-ray diffraction experiment was carried out on the bent side of the crystal at different points to see how the molecules are in that particular local point. And through that, we got to know the possible mechanism. We also did some DFT calculations to support that. And
Mhm.
and the second part was now the application part. So for that,
Okay.
we have a team, iLab in IISER Bhopal only, which is headed by Dr. Mitrudi. and his team, and they actually suggested that because this is a flexible crystal, but it was not conductive in nature, conducting crystal. It was not a conducting crystal. So we decided to create a composite. Composite is basically a physical mixture where we took one polymer which was conducting in nature, and we took our compound which was flexible in nature, and we made a composite out of that, and we used it in fabrication of a sensor which was piezoresistive.
Okay, means apply
So
some pressure. So the piezo, we have to apply some pressure, then
yes,
electricity will be generated.
yes, yes. So based on that, so there are already a few piezo-resistive sensors in literature, and the conducting material that they used was actually, it had a decent value, but the problem was that it was not flexible. So as soon as you put pressure on that, there is supposed to be discontinuity. So it is not able to restore it back. So for that, they needed a flexible material also. And the flexibility was provided by our system,
Crystal.
our organic crystal. So the conducting part was from the polymer side, and the flexible part was from the organic side, and we combined them both. So we were able to take care of two problems, the flexibility and the conducting part, and we created a piezoresistive sensor which actually shows commendable data as in terms of what has been done before. So the sensitivity is good, and even at high pressure range the values are quite good. So I think, yeah, somehow everything, it took a lot of time because of COVID and then having successful collaborations. But then it worked
But
out in
anyway,
the end.
it's an excellent
And
piece
was
of work.
yes.
Both,
And
Thank
also
you.
they
it's a
so many
new work.
objectives also they find out here. So because they designed so many things, they have to so many
So
problems was there. First of all, they try to make some flexible crystal. That is also a big challenge. And then also to make
Yes.
them conductive again, that was a challenge. So many things they solved. Again, they made it on an piezoelectric based material to prepare that. So really, it's a great,
Yes.
like so many patients needed, so many means like that, as you
yeah,
told that,
I think Avantika has nice way explain how the researcher life, how they generate the curiosity and one by matching some solving problem. It's like a game. If you find
Yes.
interesting and if you do your job best way, honest way, it will give up a good result.
success,
Means
yes.
what
That's why
you get
she
awarded. And
become highlighted at the end. She become highlighted. So many, how you can see that how so many struggle to get to make a collaboration with others to do the work.
this is the curiosity, and when we are playing some game, like if you mix together and if you solving one thing like that, researchers should be come up with this mind that they want to solve some problem. Means not like that, means they do some have some curiosity,
Yes.
and by doing that one, how we can apply that whatever I, if they are flexible crystal, what is the next? So if you answer that next, that will come up with some thinking and
But
need some good collaboration.
actually, in that, definitely, it never came to your mind that no, okay, up to this much I can publish the paper. Why you will do this again? I will do this. Not came to your mind. I think, like, definitely when like some time passes, this then it will come automatically mind. No, why I will again? I will like I have to wait for this. I have to wait for that. So better I can publish this. Uh, uh,
I have an answer for this actually, because as you asked in the beginning that don't student get frustrated, I was very much frustrated. This work continued for almost 2.5 years, out of which in 1 year no work was done. I mean, I had my result. I had a flexible
COVID
crystal.
time going is going.
Yes, and we had to collect this synchrotron data in Australia. They have to go to a different facility where this collection take place, and that was completely locked down. So we, and for several attempts, so for synchrotron facility, I think after every 3 months they get a slot. And for 2 or 3 consecutive trials, they could not get the slot because of COVID. But the good part was that during that time, I had other projects to focus on. So I concentrated on them. And it is sometimes, if you have a very critical problem, it is good to just leave it as it is for a while and look at it fresh mind on a fresh day. So that gives a different perspective. So for me, I think that happened for a year. And then the good thing was that this electrical part, the piezoresistive part, basically, that collaboration was in IISER Bhopal only. So if you have a good collaboration, you can communicate with them on a time to time basis, and you can discuss your problems with them. It's very difficult to get such collaborations, but if one finds it, it's really good. So after
Really
their
helpful.
work started, it just went on and on quite fast. So I think it had to cross that potential barrier. That's it.
Yes. I think, Avantika, this era we can say that it's not the time of competition, it's time of collaboration. If you do have
Yes.
good collaboration, whatever Avantika said, and your work will go to higher forum. Yeah.
Yes.
Oh,
thank you.
Okay.
Thank you very much. So thank you very much. So all the best for your future works. So
And
all right.
yeah,
Thanks
thank
a
you,
lot.
Avantika. Yeah, you come and give a nice talk, and it's really helpful to all the new researcher, who are looking for completing their PhD. How do they find the postdoctorate job, as well as also who are new, they how to do the research to their research. Really helpful. Thank you very much, Avantika.
thank you so much.
Yeah, after a long time.
Thank you.
Yeah.
Thank you.
Yeah.
Thank you for giving me this opportunity actually to speak to all of you. And maybe, I don't know if my inputs would be helpful to anybody, but I hope so that it is helpful to some of the researchers.
Definitely it will be helpful. So they should know that that when they start the